My name is Bruno Ngala. I'm from Cameroon. Yeah, I did my MSc in Ghent, Belgium, in nematology. Yeah, and I came to Harvard to do my PhD, and it's on using Brassica species to control potato cyst nematodes in the field. Potato cyst nematodes is quite a very important economic pest of potatoes in the UK, and it ranks second after the leaf blight disease. Yeah, it costs farmers in the UK in the range of 26 million pounds a year. This pest, yeah, it's been controlled basically by chemical nematicides and rotation, crop rotation. However, they survive for quite a long time in the soil. So rotation to effectively control these nematodes can take like 7 to 13 years. But this is not feasible for farmers in the UK because they need a quick crop to have their money back. Yeah, so most of the chemicals that have been used to control this nematode are being phased out because of new EU regulations here regarding the use of pesticides. So there is urgent needs for alternative, and one potential option is using biofumigation, which is the green manure cover crop here, which is cultivated into the soil here to control these potato cyst nematodes. And my PhD project has been focused on applying these methods in the field. What I've done so far, we've conducted 4 field experiments, and 2 of them were testing these methods for summer cultivation, that's mid-summer cultivation, and incorporating them in late autumn, while another one was focused on trying to overwinter this crop to see how it can help, because some farmers are interested in not just leaving their field fallow, but putting a crop here which they could incorporate in the following spring, yeah, so as to reduce erosion in the field. Yeah, so during each of my experiments, we try to monitor the viability of these nematodes. Yeah, that's see what this crop is doing to the nematodes in the soil when they are growing, and after chopping and incorporation, and then monitor the reproduction of these nematodes after the potato crop has been planted in the field. Yeah, so from my project here, we noticed that as this crop is growing, it's also releasing some chemicals or products here which are affecting these nematodes, because we noticed the reduction in viability of these nematodes in the soil when this crop is growing, and an additional effect when this crop is chopped and incorporated. Yeah, so we've been testing viability in different ways here, basically through hatching, in which case we treat these nematodes with exudates from the host crop, yeah, to see how many of them can hatch here by exposing them to these exudates, because these nematodes, they only hatch when they sense the exudates from the host crop, without which they will not hatch. They will just stay dormant in the field, and they can be there for as long as 20 years until they come out. They sense the exudates from the host crop. And another way we've been testing for viability is been using Medolla's blue, which is an easy way. You just expose the cyst and the eggs to this blue, then you rinse them and you observe here. Those that absorb the stain means they are dead, they are not viable, and those that are viable don't have the capacity to absorb the stain. So you can then differentiate to see how many of them have been killed by applying biofumigation. My project is coming to an end, yeah, and I'm looking forward to carry on with research here and using sustainable ways to control these potato cyst nematodes and other plant parasitic nematodes here in agricultural system. So yeah, it's been quite a fantastic time at Harper, and I've enjoyed my time at Harper. Yeah, because the facilities and the people and everything, yeah, it's been brilliant. So yeah, I'm looking forward to carry on with research and using biofumigation, yeah, and other sustainable ways to control plant parasitic pests, yeah, especially nematodes.